Hello everyone, welcome back. Okay, today I will just going with different properties of colloids. So as I have already earlier said that today I will just going with different properties of the colloids. Okay, so I have already discussed different types of colloids based upon the states of matter and the solvent affinity. So this kind of things I have already discussed. So in the lecture 2 I will discuss the properties of colloid. So you can see here, okay, that properties of colloid can be also just different point of view, like the optical properties. Okay, if I say, so just let me just use the pen. So you can see the optical properties. Okay, optical properties. So under optical properties, Tyndall effect, ultra microscope, electron microscope, light scattering, these things are here. Okay, and under kinetic properties, Brownian moment, diffusion, osmotic pressure, sedimentation, viscosity is there. I will just go one by one. Okay, so the details discussion, that what is the Tyndall effect, what is ultra microscope, okay, Brownian moment, I will just go everything. Okay, so and under electrical properties, electrophoresis, electrical double layer, electroosmosis, streaming potential, sedimentation potential, and donor membrane effect is there. So in today's class actually I will discuss the optical and the kinetic properties. Okay, so just let me erase one second. Yes, so see the optical property. So by the term only, I mean the optical. I mean optical is related to something is light. Okay. So here actually what actually you have did here, that by the help of with the aid of optical or light sources, okay, we can just get different of information regarding the size, shape, structure, and the molecular weight also. Okay, as you can see here, okay, that this study actually helps to obtaining the information regarding the shape, size, and structure. Okay, also the molecular weight of the colors. Yeah, you should remember this point also. And depending upon which kind of properties, if I say specifically, okay, the source of light, you can see the line, and the source of light and the resolving power of the optical system. What do you mean by resolving power? Resolving power means if I consider any kind of microscope, so how the actually it is able to determine or distinguish the smallest or smaller particle. Okay, the tiny particle, the microscopic particle. Okay, the ability, the power, this kind of thing actually denoted by the resolving power. So here it is written that the source of light and the resolving power can actually help to determine this kind of property, like the shape, size, all those things in a very precise way. Got my point? So that is actually the optical property. So going to the list, yes, so first one is the Tyndall effect. Okay, so many of you actually have heard about this term Tyndall effect. So what actually happened here? Tyndall effect means here actually we can differentiate between the normal solution and one colloid or any kind of dispersion system. If I tell, how can we distinguish? Let's see. In Tyndall effect, actually the property which is shown by any kind of light source, that is the scattering of light. Scattering of light means if there is any kind of dispersed phase particle, and if you just consider one thing, that is the dust particle, if it is present in the atmosphere or any kind of dispersion medium, we are actually talking about the dispersion medium here. Okay, so if there is little bit that kind of particle is present, so light can scatter on that particular particle. So after scattering, we can obviously observe that particular object due to the transmission of light or scattering of light. Okay, so that is the difference. But in solution, if I tell the solution, just try to visualize the thing, that when the light actually pass through the solution, okay, so it is coming in a straight line way. Means, straight line way means there is no scattering of light is occurred. There is no scattering of light is actually occurred. But when the light beam actually comes into the mixture of water and milk, it is also a kind of colloidal dispersion only. Okay, so here due to the presence of the small dispersed phase, so light is actually scattered there. So due to the scattering of light, so the light path is visible. So that is the difference. Okay, so it is observed due to the interaction. Just focus on this particular term, that the interaction of that particular particle, with the lights. Okay, so here narrow beam of light, you can see this is the narrow beam of light pass through any kind of dispersion colloid, then only it will scatter. What is the reason? Because there is tiny particle, that is the dispersed phase is present. But if I say the solution, there is no this kind of dispersed phase is present. Only there is solute and solvent. This is the homogeneous mixture. But this kind of mixture of water and milk, this is the heterogeneous or polyphasic system. So that is the point. And one also important point is written there, that lyophobic system show the most intense Tyndall effect, but the lyophilic, they have the little, the property, or you can say this is a very negligible kind of property, they can show the Tyndall effect. Now the question is why? Why this kind of phenomena is there? So as I have discussed in the earlier classes, that lyophobic, what do you mean by lyophobic? Lyophobic means the solvent affinity is very less, or that this kind of colloid actually hate the solvent system. So as they hate the solvent system or the affinity is very less, so here the dispersed phase is very much less soluble. So as they are less soluble, they are obviously present in the dispersion medium in a very specific and very, what you can say, organized way. Okay, so due to that reason, Tyndall effect is more prominent here. But if I tell the lyophilic, here the dispersed phase is actually very much soluble compared to the lyophobic. So that's why, due to the absence of this kind of dispersed phase, the Tyndall effect is very much in a less amount. Okay, so that is the reason that in lyophobic and lyophilic, this kind of system is actually discussed here. Okay, got my point? What is Tyndall effect? Okay, next, this is actually also said the same thing. I have told you that you have sometime observed the sunlight in any kind of in a room from the window in morning or any kind of time, mainly the daytime, you can see the ray of sunlight is coming. So and in this ray you can see the dust particle is actually moving. So what is actually happening there? That is this kind of phenomena, Tyndall effect. Okay, so I have already told, just come into the next point. That is the ultra microscope. Now see, why it is actually ultra microscope is necessary, because the particle is so too small to seen by any kind of optical microscope. Means with the help of any kind of compound or optical microscope, it is not that much easy to visualize or to observe any kind of colloidal particle. So due to that reason, so we can only observe the colloidal dispersion with the help of ultra microscope. Okay, against a dark background. This term is also necessary, you have to keep in mind. Okay, so by the help of ultra microscope against a dark background at a right angle, okay, so we can see the colloidal particle. Okay, so with the help of any kind of normal compound microscope, it is very hard to visualize any kind of colloidal particle, as it is the size is very much small, too much small. Okay, so also it is written that in the ultra microscope is used in the technique of microelectrophoresis. What do you mean by microelectrophoresis? See, electrophoresis means when there is any separation of any kind of compound or substance, like if I say the DNA, normal DNA and RNA, this kind of thing, so that things also can be separate with the help of any kind of electrical field. So electrophoresis is, determined or just defined by that way. Okay, with the help of any kind of electric field, when there is any kind of separation is actually happened, so that is defined by the electrophoresis. So here we can use this kind of microelectrophoresis also to measuring the particle image. Okay, so that is the concept of ultra microscope, that why ultra microscope is very much essential to determine the particle size for colloidal substance. So that is the reason, the size is too much small. Okay, so after that, coming to the next point, the electron microscope. Okay, electron microscope, which is very much, the resolving power is also very much high compared to the ultra microscope also. Okay, so here what actually it is written, that ultra microscope was sometimes not able to resolve the lyophilic colloids. Why? Because as I have already told, that lyophilic, that is a colloid in which the affinity of the solvent system with the dispersed phase is very high. So that's why the particle present here is very much negligible, or very tiny particle actually you can find out. Okay, so compared to any kind of lyophobic. Okay, because the most of the particle actually they are soluble, so which is actually left, the size is very much small. So that's why the concept is here that sometimes it is very much difficult also with the help of ultra microscope also. So that's why we use this kind of electron microscope. Okay, so that is the only point, and by the help of electron microscope we actually get the actual particles size, shape, and the characteristic or structure of any kind of colloidal particle. So that is the electron, or you can scanning electron microscope. You may heard about the term scanning electron microscope. Okay, so that is the point here. Okay, so next one, the property is the light scattering. So as I have already discussed in the Tyndall effect, I mean the portion only, that light scattering is a phenomena where the light actually scattered with any kind of dispersed phase, or I mean the particle. Okay, so just going to that in little bit discussion here, that when a beam of light actually pass through any kind of dispersion which is colloidal, obviously they may be absorbed some kind of light, and they may be scattered some kind of light, and some of the portion is transmitted. Okay, so now the actual colored, or that one observer can observe from outside any colloidal particle, that color due to the absorbed light, just written and see the point, the color that is actually observed by any kind of observer, that is the absorbed light. For example, also is written there, the gold chloride particle absorb the light deep red color. So obviously it will absorb like a deep red color, whereas silver particles absorb the brown, while silver iodide they will absorb the yellow color. Means the difference is that if I only silver particle is there, so they will only absorb the brown, but if there is a iodide group is present in the silver, so they will absorb the yellow color. So the different compound, they will absorb different color, and like that way they will just visible to the observer right that way only. Okay, so that is the things. Also his point is there that due to this kind of scattering of light against this kind of dispersed phase, so the colloidal dispersion always appeared like a turbid. I mean it's not that much of clear liquid, if I say. Okay, like a turbid medium. Okay, turbid means little bit opalescence and little bit system will be like that. Okay, so that is the light scattering phenomena is there. Okay, so this is all about this kind of optical properties. Okay, so okay, one point is also there that light scattering measurement are the useful of the association colloid. I have already discussed the association colloids concept. Means those are the surfactant or surface active agent. So with the help of this kind of light scattering phenomena property, it is also helpful to determine the size of that kind of association colloids. Okay, because the number of molecules of the surface active agent forming them, also studying the nature of proteins and also the natural synthetic polymer. Okay, so with the help of this kind of property, I mean the light scattering property, we can also determine various proteins, I mean the property, their nature. Okay, how much the protein bonding is there, this kind of thing also we can determine, or we can just measure with the help of the light scattering effect or property. Okay, okay, so now the kinetic properties of the colloidal particle. So see, what do you mean by the kinetic term? Kinetic means something related to the motion or movement. Okay, something related to the motion. If I say the motion, okay, means it is not in static condition. So now see, with the help of, or depending upon this kind of kinetic phenomena, what are the properties? So this kind of kinetic properties of colloidal, they can be useful to predict the stability of the system. Okay, so how much actually the colloidal system is stable, we can predict with the help of this kind of kinetic property. And second one, we can determine the molecular weight of the particle, also the transport kinetics and the colloidal particles. Okay, transport kinetics, I mean the motion, the movement of that particular colloidal particle. Okay, the sedimentation, the viscosity, all those things. Okay, all those things will be, can be just determining, or can be just useful to predict this kind of things. Okay, by the help of kinetic properties. So first one is the Brownian motion. So Brownian motion, there actually have little bit concept regarding the Brownian motion. So just if I just give me some time. Yes, now you can just see it properly. That first of all, the particle size obviously as large as about 5 micrometer. So this is the important point, the particle size. Not every particle will show this kind of Brownian motion. Okay, there should be some condition. So the scientist Robert Brown first proposed this kind of theory, and Brownian motion may be exhibited so the particle which have the size range like the 5 micrometer. That is the first point. And after that, this kind of Brownian motion, they always keeps the particle in the motion way. So as they have in a motion or movement way, obviously there should be some thermal energy can be produced. So that's why it is written like that, thermal energy keeps the particles in the motion. Also they can collide with each other, okay, with the wall of the container, because all the particles actually randomly moved. Okay, so that's why they can be collide with each other and with the wall of the container also, where they actually kept. Okay, so this collision charge is direction and velocity of the particle. So got my point? So the collision change the direction and velocity of the particle also. If the collision is more, obviously the velocity will be more. If the collision is less, so velocity will be less. Okay, the velocity of the particle increases with decreasing the particle size. What do you mean by this? Obviously, if the size of the particle is very much less or decreasing way, so then the velocity of the particle will be increasing. I mean the movement will be increasing. That's kind of things. Okay, and increasing the viscosity of the medium decreases and finally stops the Brownian movement. So if we increase the viscosity of that particular colloidal dispersion medium, so the Brownian movement can be decreases or finally it can stop also. So that is all about the Brownian motion. So now the diffusion. So what do you mean by diffusion? What do you mean by diffusion? Diffusion means when the particle actually moves from any kind of higher concentration to the lower concentration. Okay, higher concentration to any kind of lower concentration, that is actually mean by the diffusion. So it is a spontaneous process, and here the process solute molecules move from a higher concentration to the lower concentration until the concentration obviously in a equilibrium or becomes uniform. Okay, so that diffusion here already written that diffusion is expressed by the Fick's first law, that is the dq by dt equal to minus ds dc by dx. Okay, so what did this kind of term is actually, so this will be small d, not the capital D, this will be the small d, I mean dq. Okay, so dq means the amount of material, dq means the amount of material diffused in time dt across any area S, okay, under the influence of any kind of concentration gradient dc by dx, and d is the diffusion coefficient and has the dimension area per unit time, Okay, so this is the actually first Fick's law. The Fick's law will be just discussed in the later on in the different classes also in the pharmaceutics. So you have to remember that the diffusion, the rate of diffusion actually expressed by the Fick's first law. The MCQ may be come in the competitive exam. And on point is also written that the colloidal particle also exhibit the diffusion, which also results in the Brownian movement. Means if there is any kind of diffusion is happening, so that leads to the Brownian movement also, because these all are the coming under the kinetic property. Got my point? These all coming under the kinetic property. Okay, next one is the osmotic pressure. So what do you mean by osmotic pressure? Now this is the pressure actually needed to stop the movement of any kind of particle throughout this semi-permeable membrane. That is the osmotic pressure. And osmosis means when actually any kind of substance or liquid passes through any kind of semi-permeable membrane. So that is the osmosis. And osmotic pressure is means that the minimum pressure which is required to stop this kind of movement. Okay, so that is the osmotic pressure. And what it is written here, that osmotic pressure, it is a colligative property. Okay, in the pre-formulation study of the pharmaceutics different properties, you can just study regarding this colligative property. So now the focus on the things that the colligative property and this kind of osmotic pressure. See, osmotic pressure, it depends upon the number of particle in the dispersion, right? So number of the particle can influence or can affect this kind of osmotic pressure. So in case of the associated molecule colloids, I mean that surfactant, each aggregate, I mean the micelle, if I talking about the micelle, act as one particle and the osmotic pressure is small. Got my point? So if I consider any kind of micelle, that is the aggregate of any kind of surface active agent, so the osmotic pressure is too small for them. Okay, but osmotic pressure can be used to calculate the molecular weight also. How can it use? Just zoom it for your better visualization. Okay, so like see, P equal to C by MRT. So P means the osmotic pressure, C is the concentration in gram solute per solvent, M is the molecular weight. Okay, so from here you can determine the molecular weight of that particular colloids, and R is the real gas constant and T is the temperature. So you should remember this kind of thing. Okay, that particular formula osmotic pressure, that from that you can determine any kind of molecular weight of the particular dispersion medium. Okay, so that is the all about the osmotic pressure. So now the sedimentation means due to the under the influence of the gravitation force, when the colloidal the dispersed phase is coming downward and they have just formed a hard cake or any kind of flocule. It may be deflocculated or flocculated. So the difference between the flocculated, deflocculated, you will be learning later on in the suspension chapter. So as of now, just understand the point that when the under the influence of the gravity, the dispersed phase is actually coming downward and they have just making any kind of hard cake or floccules. So that is the sedimentation process, and sedimentation process is obviously not desirable because it is the indication of the instability. But you can see here what it is written, that in normal dispersion the dispersed particles obviously tend to settle under the influence of gravity, but in case of the colloidal dispersion the Brownian movement tends to offset the sedimentation. Got my point? So just use the pen, that normal dispersion there is a case of this kind of sedimentation, but for the colloidal dispersion, as there is a Brownian movement, so obviously this kind of sedimentation or settle down of that particular dispersed phase due to gravity will not occur. So you can say also that Brownian movement is the reason for stability, or Brownian movement can provide the stability of any kind of colloidal dispersions. So you can explain this kind of concept as the Brownian movement not help or tends to offset this kind of sedimentation. So that's why this kind of sedimentation will not be happen. Okay, so stronger force must be applied to bring about the sedimentation of particle. So if we can give any kind of stronger force which can neglect or which can just ignore this kind of Brownian movement, so then sedimentation can be happen. Like ultracentrifuge generally used to bringing about the sedimentation of sedimentation of the colloidal dispersion. So ultracentrifuge can be, the method can be applied. Okay, in an ultracentrifuge the particles settle according to their molecular weight. So we can determine the molecular weight also. So the higher molecular weight particle will be dispersed or settled in the very bottom, and just following this kind of order. Okay, so by that kind of ultracentrifuge we can determine this kind of molecular weight also with the help of sedimentation process. Okay, so these also are these kinetic properties of the colloidal dispersion. And last one, that is the viscosity. That viscosity of the colloids, it can be depends upon the shape of the colloidal material. So as I have already discussed in that particular shape portion, that if the linear shape is there, the viscosity will be little bit high, but if there is a spherical like shape, the viscosity will be less, because the viscosity means what? This is the the any kind of obstruction or any kind of you can see the friction. Okay, when the flow is happen, so when there is a obstruction during the flow of any kind of fluid, so that is the viscosity. Okay, right, it is like a resistance, you can say. So if the shape is like a linear way, so obviously the viscosity may be high. Okay, so here it is also written that the viscosity of the colloids depend upon the shape of the colloid material, and viscosities provide a means of detecting the changes in the shape, flexible colloidal particle and the macromolecules. Okay, so viscosity can also be give us the idea regarding this kind of things. And the last point is viscosity studies also provide a means of determining the molecular weight of the colloidal particle. Okay, so why it is written like that? Because if the molecular weight is high, okay, so we can get a little bit idea that maybe the viscosity will be high because the interaction forces, the intermolecular bonding, these all are very much high. Okay, So that is significance, or that is a little bit I mean the indication of the higher molecular weight. So that was the property I have discussed today. Okay, so one recap is I just I just a little bit time should be given. Like optical properties, we have heard about the Tyndall effect, ultra microscope, electron microscope, this kind of things. And under the kinetic properties, you should remember this kind of Brownian movement, diffusion, osmotic pressure, sedimentation, viscosity. Right. So thank you everyone. So in the upcoming classes, I will go with the electrical properties, and after that, as the syllabus is already directed by the PCA, I will go one by one. Okay. So thank you once again. If you have any kind of doubt, you can ask me in the channel chat box also. Okay, so thank you once again.